Right, hi your 11s, this is Miss Lim here again, and this is our third video in aqueous solutions about solution saturation. So let's get started. Right, so we're going to be learning about some terms and how much solute you can put into a solvent. Right, so there is a limited amount of solute that can be dissolved within a given volume of solvent at a given temperature. So there is a limit on how much you can dissolve. Right, if there is no limit, if you've got something that can infinitely dissolve until it becomes the solvent because there's so much of it, and the other substance becomes a solute, it's called miscible, right? And it's generally with small organic molecules, which you'll learn about in year 12, right? If less than the maximum amount has been added to this mixture, the solution is said to be unsaturated. So you put less than the maximum amount, it's unsaturated because unsaturated kind of means that you can fit more in, and that's why it's less than the maximum amount, because you can fit more in, right? If equal to or more than the maximum amount has been added, the solution is said to be saturated, right? So effectively, if you add too much, then you reach that maximum and it can take no more, then it's called saturated, i.e. it can't take any more. Most of the time, that extra stuff will be in the solution as a solid sitting on the bottom of the beaker. All right, so you might see a beaker, you put some salt in there, it dissolves, okay? You put more, you put more, you put more, you put more, right? And at some point, there'll be a little bit of sodium chloride that can no longer dissolve in that water, and that will be that extra bit. Okay, so saturated solutions generally have some of the undissolved solute at the bottom, right? If you see undissolved solute, then generally the solution is saturated, right? So that's definitions of saturated and unsaturated. Right? And then we can tell if something is saturated or unsaturated by using some of these solubility charts. So what these do is that they show the maximum amount of a particular substance that can fit into X amount of water or X amount of whatever solvent you've got. All right, so you can see here that this is showing the solubility in grams of particular ionic substances in 100 grams of water. And you've got different chemicals here, which they show, each of those lines show the maximum amount at a certain temperature. All right, so if we look at this KCl line, let's have a look at it at 50 degrees Celsius, that point there, approximately, you would track back here at 50 degrees Celsius, so that, yep, we got the right temperature. It can approximately fit, and you would use a proper ruler here, it can fit approximately 43 or so grams of that KCl at 50 degrees Celsius. All right, so we can check if things are soluble or insoluble, or sorry, not soluble, insoluble. We can check if substances are saturated or unsaturated if we are asked, how much is in a certain amount of water, using these charts. So let's have a look at the first one here. So let's say we have 40 grams of KCl in 100 grams of water at 70 degrees Celsius. So again, we're using that KCl. So let's, oh, goodness. Okay, let's use that KCl here. We're talking about 40 grams in 100 grams of water at 70 degrees Celsius. So let's look at 70. That's over here. 40 grams is over here. So the intersection of those 2 points is here, right? And it's in 100 grams, which is that 100 grams there, so that's fine, okay? Okay, so we look at that position of that green dot. That's the question, saying it's this much here in this much water at this much temperature, right? And we look at its position relative to the maximum amount, and we see that it's lower than the maximum. So we would say that this substance here, or this solution here, is unsaturated. Okay, unsaturated there. Okay, let's have a look at the next one. We've got 30 grams of calcium chloride in 25 grams of water at 20 degrees Celsius. So the important thing here is to see is that this is not in 100 grams of water anymore, right? So this is only in 25 grams of water. So if it's 25 grams of water, we might convert that into what that would be if it was 100 grams of water. So 25 is a quarter of the water, right? Or you can consider it as 100 over 25 is the multiplier. So the multiplier, therefore, is 4, right? So you would need to, you'd be thinking about 4 times as much calcium chloride in that 100 grams of water. So you would say 4 is the multiplier, which you need to apply to 30, which makes that 120 grams in 100 grams at 20 degrees Celsius. Okay, so we would need to convert it into whatever mass of water or mass of solvent that you've got in that particular table. All right, so we would say then, okay, let's go find those 2 points here, right? So we're using the yellow at 20 degrees Celsius here, 120 grams, which is all the way up here, right? And so you would go up here, right up here and over across here. That's where the thing is. Okay, so it's off the scale, right? And it is above that line. So you can see the line for calcium chloride is here, and it's going to be above that line, which means that it's going to be above the maximum, which means that this substance is going to be saturated. Saturated. Okay? Can't fit that much in. So it's going to have like some left over at the bottom. Okay? You could even work out that, oh, actually, yeah. Okay, cool. Let's do the last one. So we got 60 grams of KClO3 in 150 grams of water at 70 degrees Celsius. So in this case, we're putting in at 150 grams, which is too much water. So you would do 100 over 150 is the multiplier, which is 0.667 or 2/3. All right. And so you would say that in 100 grams of water, you would apply the 2/3 to the 60 grams. And so therefore, that would effectively be 40 grams in 100 grams at 70 degrees Celsius. Okay, so 40 grams in 100 grams of water would be the same thing as 60 grams in 150 grams of water, right, at 70 degrees Celsius. Let's go find that point. We'll use the blue color, even though I didn't use the blue highlighter. 40 grams at 70 degrees Celsius, so 70 degrees Celsius again, right? 40 grams again over here. So it's again at this point here. Oh, wow, look at that. Okay, and it is of KClO3, which is this one here. Okay, and so that is above that line, so that one is saturated as well. Okay, so you can use this chart to work out whether things are saturated or unsaturated depending on how much it fits in that particular mass of water, and you might have to do a bit of conversion to do so, right? Okay, so the temperature of the solvent will determine how much of the solute can be dissolved in the solvent, and so we saw that in the in that chart because as you saw the temperature increased, generally. For ionic solids, the higher the temperature, the more solute could be dissolved in the solvent. All right. Okay, so for gases, the higher the temperature, so this is different, the less solute can be dissolved into the solvent. So generally, you want cold liquid to dissolve gases. All right. Also, for gases, the pressure above the liquid can also determine how much solute can be dissolved in the solvent. The higher the pressure, the higher the amount of solute can be dissolved in the solvent. And so this is why fizzy drink bottles are under pressure, right? So you have your fizzy drink bottle, here is your cap, right? And here is all your fizzy drinks. Now you'll notice that in your fizzy drinks, there are no bubbles generally until you open it. When you open it, right, you will hear a ch sound, and that's all of the high pressure gas inside here escaping, right? So here it's at a high pressure compared to the exterior, and when you open it, all of this pressure goes away. What you'll notice then is that immediately bubbles will start to come out of the cold drink. Those bubbles will come out of the cold drink because all of a sudden the pressure above the liquid is much lower than it was before. Therefore, less solute can be dissolved in that liquid. Since less solute can be dissolved in that liquid, the gas comes out of solution, right? If this was a warm drink, a warm thing, then lots and lots of gas will come out. If it's a cold one, not so much gas will come out, right? When you drink the cold fizzy drink, when it goes into your mouth will generally warm up the solution, right? Warming up that solution will again cause further solute, the gas, to come out of solution because less can be dissolved at that higher temperature, right? So that's why that's why colder fizzy drinks are much more fizzy than warm fizzy drinks, right? That's the idea. Okay, cool. Right. So, lastly, a special kind of solution called a supersaturated solution can be formed when dissolving certain solid solutes. Okay, so a supersaturated solution, which is different to saturated or unsaturated. Right. A supersaturated solution is a solution where more than the maximum amount of solute dissolves in a given volume of solvent. Now, when we say dissolves, it means that it actually fully dissolves. It means that there is no solid left. So, if you say that, okay, if I put 50 grams of solute in here, right, and it's above its saturation point, so 50 grams in there, it's too much. So therefore, there will be some undissolved. This is saturated. But this one over here, because it's supersaturated, right? There's no ionic solid at the bottom. It's all dissolved, even though there's the same amount, and this is what it means by a supersaturated solution. All right, so they are formed by heating the solvent to a higher temperature first. Then you add a ton of solute to a high degree, but not past the higher temperature saturation point, so that it's all dissolved. So effectively, what you might do is over here, heat this amount of liquid up to a high temperature, drop in the 50 grams of the solute, right? It should all dissolve in there because it's less than the saturation point of that higher temperature. Then cool the solution down slowly. Now, when you cool it, in general, you'll be reducing its solubility, and therefore, in theory, it should come out of solution, just like the bubbles come out of solution in a cold drink, right? However, if you cool this correctly, if you cool it slowly enough and your beakers are clean enough, none of the solute will come out as crystals, and it will stay dissolved in the solution, and you'll have like a clear liquid, which is just supersaturated. Right, so once cooled, the solution is now supersaturated. Any disturbance in the solution, such as shaking it or adding a small amount of solute to it, will start seeding a point for the solute to come out of solution, and it will rapidly do so. And the solute past the saturation point of the solution will become solid again. So as soon as you drop a tiny little bit of thing there, all of a sudden, massive amounts of solute will suddenly start to form as a solid, and then you'll end up with that same situation where you'll have this much, which wasn't supposed to be fitting in there, now as a solid form. All right, so that's the idea of a supersaturated solution. All right, not all ionic substances or not all solids can make supersaturated solutions, only certain ones can, and you have to be generally quite careful with them. And they have limited applications, but that's how you make them. All right, and that's it. Adios.